sorry. So I should say the ECS sponsored this, so give them kudos and all that kind of stuff. Okay. We are very excited to have Brian give a talk today. He's undergrad here. What year?
Pre-senior.
Pre-senior.
4 or 5. So
pre-senior. 4 or 5. Pre-senior. CE, computer engineer, and he's worked at Datascope Analytics for
over a year now.
Over a year. And so you can see from his bio, he's done work with quite a number of people: P&G, Thomson Reuters, lots of other well-known companies. And your work has been featured in something called FlowingData.
Yeah, it's a great blog actually by a guy named Nathan Yao about data visualization. So it's flowingdata.com, and actually it's just really good to read. Really cool stuff on there. So
awesome. And so Datascope Analytics is founded by 2 Northwestern grads.
Yep. One who's here, Mike Stringer, in the toboggan, and the other, Dean Malmgren. They came out of that MRL lab.
Awesome. So he's going to tell us today about some of the work he's done at Datascope over the past year.
Yeah, absolutely. Also just going to preach a little bit about design. So we'll get started, I guess. Like Jeremy said, I'm an NU undergrad in computer engineering, and I've also worked for Datascope Analytics for a little over a year through what's called the co-op program in McCormick. So co-op is basically means I alternate quarters between studying here and working there. It's been a really great opportunity for me to learn about a lot of different stuff. So I'm just going to throw this out there to start. A lot of you guys in here probably know more about machine learning than I do. I'm not going to spend a ton of time tonight talking about training sets and support vector machines and all this and that. What I am going to talk about is design and thinking about yourself as a designer. If you think of a designer, somebody that you would call a designer now, you probably think of skinny jeans and Adobe software, maybe this guy. But my belief is that practically all of us are designers. I mean, we're all making things that other people have to use at some point. And so I think it's important for everybody, no matter what they do, to know a little bit about this stuff. And so first we're going to start with something that is a little more familiar, which is the way that you might approach something just from a purely machine learning perspective. And I've seen things approached this way by people in the real world who work at machine learning companies. And that process might look a little something like this. So first you got to decide what it is that you want to do. So maybe a company comes to you and they say, we want to understand our customers better. You guys are in machine learning, we've heard of that, so work on that. So then after that you might start by trying to get the data. So this is a common theme, right? You got to go all over the place. You got to gather the data together and get it into the formats that you can use it in, pull it out of old databases and clean it up and do all that kind of stuff, and sometimes this can take months. Then you got to decide sort of, okay, what is it that we're going to do with it? Maybe it would be useful to classify it. Maybe it would be useful to cluster it. We have this sort of set of tools in our arsenal that we know that we can use, and okay, here's what we're going to do. Then you do it. So you build the software to do it, which usually isn't something trivial, and it's usually something that's designed to scale up for really big sets of data just in case you need to do that. And then you're going to work on making it more and more accurate and just sort of refining your algorithm and your approach over time until you're providing some sort of insight about this person's customers. So just an example, and full credit to Mike Stringer actually, who's used this one too before. Have you guys heard of the Netflix Prize? So the Netflix Prize was a thing that started in 2008. And Netflix said, hey world, here's $1 million to anybody who can improve on our recommendation engine by 10%. And here's a data set and some rules so we make sure that the competition is fair and that kind of thing. And over 5,000 teams competed in this prize. And it actually took the winning team 2 years to develop something that got 10% better than Netflix's existing algorithm before they started this thing. And then what came out of all of that? Well, Netflix did use one of the algorithms that was submitted in the first year of competition, but they didn't actually end up using the one that won. So this is a quote from one of the guys at Netflix who was running the competition, and they basically decided it was going to be too much engineering effort for not enough payoff, to be able to, squeeze out those last 2 percentage points on recommending movies. And at this point also, Netflix's business model had shifted because in 2008, they were a company that shipped you DVDs in the mail. And then in 2010, people were streaming like crazy. So over the course of this competition, what they needed to get done actually had totally changed, and at no point had they said, okay, slow down, 2% better recommendation isn't going to save us anything because we're not mailing movies to people anymore. They can just watch 5 minutes of it and then go watch something else if they want. But here's a different approach, right? If you didn't think about it as okay, let's make our algorithm 10% better, but let's provide better recommendations, you might have come up with something completely different. So I don't know if any of you guys use Netflix, but if you think about what could make your Netflix recommendations better, it might be that you share your Netflix billing account with somebody else, like, a girlfriend or a roommate or something like that. And there's no way to differentiate when you rate a movie or when you watch a movie who's watching it. So if they had taken that $1 million and spent it on making sure that on my Netflix, it doesn't come up because you watched Real Housewives of Beverly Hills when, my roommate had just done that, that might have improved their recommendations by way more than spending $1 million in 2 years on trying to squeak a little bit more out of this algorithm. So where's the problem in this chain, I think the problem is at the very beginning. It's in thinking that you, A, know what the problem is, and B, know the right way to solve it. Just without asking anybody else, without asking the people who actually use your thing. That's actually kind of crazy. It'd be like going to the dentist and saying, I'd really like you to use the drill. I read about the drill in Forbes. Some other people I know are using the drill to solve their problems. Could you use the drill on me? Well, if you're a good dentist, you're going to step back and say, okay, hold on a sec, let's take a look. And that's what design is about. Design is about taking a look. And if you don't get anything else out of this talk, it should be what's on this next slide, which is that machine learning is a tool, but design is a process. Machine learning is an awesome tool, right? It's allowing us to do things that we've never been able to do before, and it's a really exciting field right now because of it, but it doesn't replace good process when it comes to solving real problems. So let's take a look at how you might solve a problem from a design perspective. So same starting place, right? We think we know what's wrong. We think we know how to solve it. But the difference in design is the next step, and that is clarifying the problem. This is really the beauty of the process, is that by the time you even start building anything, you understand clearly what it is you're building, who you're building it for, and why you're building it the way you are. And how do you clarify the problem? There's a few ways to do that. So one of the techniques is user research. So user research means going and actually talking to the people who are going to use this thing. And I know it's kind of hard if you're not building something like an app or a dashboard to think about users, but there are users of all kinds of different things. I mean, you might be making a report for upper-level management. Well, then the report is your thing, and upper-level management are your users. You might be making a software module or an API. In that case, the programming community are your users, and your thing is that API or that software module. So no matter what it is you're doing, there's probably another human who has to deal with it, and you want to go out and talk to them before you go about trying to make this thing, so you can really understand what it is that they need. And so another thing about sort of clarifying what it is that you're going to do, clarifying the problem, are making mock-ups. So this means early on, spending just like a little tiny bit of time on making something that, it's not at all what it's going to be eventually. It's something you could throw away probably, less than half an hour on something, a sketch or something made out of paper like that, or it could be a quick script if you're writing software. Just making something that gets the idea across that maybe you can show to your user and they can say, oh, I don't like that part, I like that part, and they're not afraid to because it's clear that you only spent 20 minutes on this thing, But also that idea of thinking of what you want the end result to be before you even start thinking of the details of how you're going to make it. So if you're making a report for somebody, you might maybe just sketch out like 10 different charts or visuals that you might include in there, or something like that, and show them to them, and they'd be like, oh, this one would be really helpful, I've never seen anything like that before. Well then, now you know that you need to plot this against that. Now you know that you need to be able to do this analysis. It might be able to help you make decisions about if you're doing something with machine learning, what kind of algorithm, what kind of infrastructure you'll need to be able to support the thing that the person is actually going to use in the end. So designing with the thing that the user is going to interface first, and then having everything that leads up to that second. So if we go back to that process, we've got a problem. We're pretty sure it's a real problem, people actually have it. We understand what kind of problem it is. Now we can actually get to building something. So this is the difference, right? When you're following a design-based process, you're going to spend a lot of time figuring out what it is you're going to do, and then you're going to be able to sprint. You're going to be able to throw something together pretty quickly because you really understand what it is you need to make. But I call it a prototype because it still shouldn't be something that you think of as a final thing. It could be, it's just sort of a first draft that you can then show the users again, because the last piece of a good design process is just doing it over and over again. So repeat until you run out of time, money, or until you get bored. And what that means is taking that prototype and bringing it back to the users and saying, hey, look what I made. And they'll say, okay, that's great, but maybe it doesn't look nice. Then okay, go back and make it look nice. Or it's not fast enough. Okay, go back and make it faster. Constantly doubting whether you know what it is that they want, showing them what it is that you've made, and hearing what they have to say about it. And a lot of this stuff seems pretty obvious, but it actually is kind of a difficult thing. Because these aren't really muscles that we exercise every day, going out and talking to people and asking the right questions to understand what they want. Now, luckily, if you do it enough times, you start to get better at it, and that's why there are companies that just do design, right? But it's totally something that's worth doing and worth learning about. So now I'm going to pivot a little bit and talk about some things that I've learned at Datascope, which is maybe more what you're expecting out of this talk. But these also kind of tie into the whole design thing. So one problem that we had, just to give a little background on this before I pull the demo up, is that, so Datascope used to have an office in Lakeview, off the Belmont stop. So if you know that area, there's lots of great restaurants, and we used to go out for lunch all the time, go for long lunches, and there were brunch places, there were Mediterranean places, and almost no chains, lots of just little unique, relatively inexpensive places to eat, and that was pretty great. Of course, our office at Belmont was way too small for Datascope, so we ended up moving down to the Loop. The problem with the Loop is that nobody lives in the Loop. So there's no food there beyond like quick lunch food for executives who need to cram down a sandwich before a meeting. And I mean, I love Popeye as much as the next guy, but it just doesn't match up to what we had before. So, we knew about these food trucks down there. And really the only way there was to figure out where the food trucks were was Twitter. So most of the food trucks post their locations on Twitter for the day. They'll say, I'm at Madison and Wacker, and I'm going to here at 2:30 or something like that. So you follow the food trucks you like, or you follow like a food truck list or a food truck aggregator of some type. But you have to go onto Twitter and just sort of read through this big column of tweets, like these little 1 or 2 sentence blurbs, and then try to construct in your mind, like, where are they? Is he still there? Like, where's the one that I really like today? Where even are those cross streets? When you move down, like we moved down to the Loop, I'm still getting a hang of where the streets are down there. So we ended up building this thing that we called Lunch. And let's see if I can switch into it. There it is. This screen is not the same as that one. Alright, this might not demo great on a projector, but we can show it afterwards too, if you guys are interested. Okay. There we go. Cool, so this is lunch. So actually, this is kind of a snapshot of data that I took at lunch time today. just because I figured it'd probably be more interesting, because now they've probably mostly packed up and gone home. But this actually does work off of that same Twitter data. So it takes plain text from Twitter and finds locations, and then places those trucks on the map. And then it also has, over here on the side, I talked about sort of those two use cases we have, which is, one is I want to know who's near me. So it does have a locator. This will just jump us up to Evanston. There's nothing up here. But if we go to the loop, you know, so Datascope World Headquarters is somewhere around here. So we might click over here and say, oh, who's on Madison and Wacko today? And here are the location tagged tweets from those trucks. So we know, okay, Tamale Spaceship's up there, we can walk there for lunch. Of course, if you also have a favorite, like Southern Mac and Cheese or something, you can click on that. There we go. So, and then that'll jump you around to where that truck is today if you really had a hankering for a sandwich or something like that. And then it also has Hyde Park, because that's something that's happened a lot frequently. I guess they don't have internet in here, that's probably why. Because down in Hyde Park there aren't a ton of restaurants, so they've realized that, oh, we can go down there and people really, really want food truck food. But anyway, you know, this was something that started off as just a simple Python script that took in tweets from a Twitter list and looked for street names and just spit it out into the terminal. And we used that for a few days, and it kind of worked, and we learned what sucked about that and what didn't, and just sort of iterated. In this case, the users were us, so it was pretty easy to do the research, but we just kind of kept building on it until it had all the things that we wanted. We're still building on it, actually. So that's that. And you guys can play around with this too at lunch.datascopeanalytics.com. One of the other employees there recently added a sort of a beta mobile interface for it. So it works on phones now too, which was something that was a big thing we've been working on for a while. Let's see if I can get back into, yeah. So that's that. And now maybe something that we actually got paid for. And you know, something a little more interesting as far as the data analysis type of stuff goes. So there's a little bit of background. There's this whole industry called e-discovery, which I had never heard of, and you probably haven't either unless you're a lawyer. But to use a modern example, say Apple sues Samsung. So when that happens, there's this process called discovery which has to happen, which means Samsung is legally obligated to provide all documents relevant to the case to Apple's prosecuting team, so that they can look through them and say, okay, here's where that email is where he said, yeah, they have a patent, screw it, or whatever like that. So they have to turn all that stuff over. And if they are judged by the court to have not done so, then the judge can invoke what's called adverse inference. And what that means is that the jury is instructed to literally assume the worst. They're supposed to say, the jury is instructed to assume that if there could be a document that supports an argument that Apple made in court, they're to assume there is one, even if there wasn't. So that's really bad. Companies don't want that to happen. What's also really bad is giving Apple your entire email server and having them see, you know, what's coming out next fall, what you're putting in your next phone, all of these trade secrets. And there's millions and millions and millions of emails that they're all keeping these days. So you got to sort through that somehow, find the stuff that's relevant to the case, turn over enough of that that the judge doesn't lower the hammer on you, but not turn over so much that you're turning over company secrets. And so traditionally, the discovery industry, the way that they've done that before there were millions of emails, was they basically got a warehouse full of lawyers and had them read through every single one. Or not every single one, but at least enough that they could prove that they tried. And as you can imagine, even lawyers who have to go to a warehouse and read emails get paid a lot. So that gets expensive and takes a lot of time, and they're also not very good at it. So you can imagine if you had to sit in a room for 8 hours a day and read some other guy's emails about the company holiday party, you'd probably just click no a lot. And when there was finally a yes, you might miss it. So actually, both Mike and Marcel, who are here, worked a lot on this project, and they could talk even more about some of the specifics about it afterwards if you guys want. But this is a shot of a piece of the dashboard that we ended up developing for them. And the solution that Datascope came up with was, well, lawyers are pretty good at some things. They're pretty good at legally ambiguous documents. So when we started off, when you start off, we have 5 million emails. Say there's a big map here, and there's emails all over the place. The emails that are closer to each other are more related to each other. So over here might be a clump of emails that are about the holiday, the Samsung holiday party. And over here might be a clump of emails that are about developing the Galaxy Note 7 or whatever. So there's millions of emails. When we start off, we don't really know which one of these ones are relevant to the case. You can actually think about it as a probability, right? There's a chance that a document is relevant to the case or not. And at the beginning, it's pretty unclear. So we have some lawyers read some, and they mark them yes or no. So now, if we know that this one that's about the holiday party is not relevant to the case, then we know the ones that are similar to that one are also probably less likely to be relevant to the case. Likewise, if they read this one about patents is relevant to the case, then the ones that are close to that one are much more likely to be relevant to the case. So you can sort of do this in phases, and as you build that out, you can keep feeding the lawyers the most ambiguous documents until you create, the most sort of polarized map of is this relevant and is it not. And again, I might even be butchering some of these details, so if you guys want more, we can talk afterwards. But as much of a challenge as that was, and a fun, machine learning problem, another problem was making it so that, making it such that the people who use this thing, which are the people who, A, manage the warehouses full of lawyers, which is actually not so far from the truth, and B, the people who are paying for this thing, law firms or Samsung or Apple, who want to be able to see, okay, how many more lawyer hours do we have to pay for before, we can say in court, we did enough. And so we were able to, this is a piece of the interface where we show this time series down here, which has a volume of reviews. So a review is a lawyer looking at something. And then it has a chart of F1 accuracy. So you can see as you review more, it goes up over time. And you can also see over here there's some error bars which show that, we're not quite sure, but you can set a goal, which you don't actually have to set very high to exceed human standards. And if you do the amount that you did before any of this stuff existed, then you'll actually be a lot more accurate than past reviews were, because you're always feeding the lawyers the most unclear ones. And then also up here, we built a few tools to help out with things that were common problems for the people who use this dashboard. So one is, how much is this thing going to cost me? Because if it's a case over, if somebody's suing somebody else for $500,000 and you're going to pay $250K to lawyers to read documents, that's not sort of a proportional response. So you don't actually have to do that. You only have to sort of respond proportionately to what's at stake for the case. Or maybe you just want to settle out of court because you don't have to deal with any of that stuff to begin with. And then there's also just sort of this accuracy stuff up here. You can see these little question marks. We built in a lot of things because, teaching accuracy and sort of false positives and false negatives and all that stuff is pretty difficult to do, especially for lawyers who might not have ever had statistics stuff or any of that kind of thing. So we made sure that our interface had lots of explanations of what those terms meant. We actually made sort of an interactive slideshow that we called Accuracy for Lawyers, kind of like the For Dummies series, so that they could step through it and we could explain to them, here's what a true negative, or here's what a false positive, false negative means. Here's what those mean in the context of people reading, your company's emails. And here's why you want to move these out of these squares into the correct ones, or something like that. So just to sort of cover some of the things that I've learned, both by working on design projects here at Northwestern and at Datascope is one, to start small and iterate. So that happened on both of these projects that I just talked about. I already mentioned the Python script for Lange, and with Dages we started with a test set of data and basically did a proof of concept before we didn't start trying to build a piece of enterprise software. That's just like so daunting and difficult to understand what people need. It's easier to start with something small, get feedback, and then go, oh, what if we add on to it until it's something fully fledged. The second thing is to complicate only if necessary. So I didn't talk much about the stuff going on in the background with the Lange thing because it's actually pretty dead simple. There's not really any complex machine learning stuff going on there. It's mostly regular expressions and looking for names of things like skyscrapers, where we looked at the tweets and saw they were frequently saying these things. And that proved to be good enough for us, especially for this application where it's not mission critical that you don't know where the food truck is today. And you can always just go read it anyway if you make it accessible. And that kind of leads into the last point, which I think is probably one of the most important ones, which is to let humans be good at human things and let computers be good at computer things. I still remember the first computer science class that I ever walked into in high school. Mr. DeWitt came in and he said, guys, computers are stupid. And everybody laughed a little bit. And he said, no, really, they're really good, really, really, really good at math. They're really, really, really good at logic. But if you think about the amount of effort that has gone into teaching computers to do the types of things that just come naturally to us as humans, it's actually kind of staggering. And it's really great that those things are moving forward. But when you're designing something, you got to take into account what humans are good at and what computers are good at and have them do what they're good at right now. And I think that's, maybe kind of heresy at a machine learning meetup to say, just let the humans deal with it. But it's kind of what I believe, focusing on the people is important. In the Lange example, if we go back to that actually, you can see, if we click on this truck, it says, sorry, 125 South Park, off the road for catering. So we could have spent a long time trying to train an algorithm to catch every time that a truck tweets an address and also says that they're not going to be there. Or we can just make the tweet such that you can click on it, read it in probably less than a second, and make the decision for yourself. So sometimes, you have to weigh which efforts are worth doing and which ones aren't. I guess that's pretty much all I have to say. But I'd be willing to take some questions if people have any about anything, working in data science, design, any of that stuff. But thanks for listening.
Can I ask how many lawyers lost their jobs?
I don't know. Do you have any estimates? I think they're probably just reading less about cookouts. They're probably just reading less about cookouts and more about things that are actually valuable. I don't know. Yeah.
So on the results of the e-discovery thing, I noticed the recall was pretty low, right? Did you choose to value precision over recall in that, or was that a reason?
That's something that either Mike or Marcel could probably answer better than I can.
No, there was so we were maximizing F1.
Yep.
Did you extract features? If so, what were the most useful features in emails?
Oh, taking features out of emails? I'm not sure. I think that the threading and or I don't know if we had thread data, but the subject lines and some of the other metadata did get used in creating those clusters, right, Mike? Yeah. So I don't know which ones were the best indicators of similarity, or if it was the body text. Do you know if we ever looked at that stuff?
We looked at a lot. I'd be happy to talk about it more.
Sure.
In terms of the design, so you learned it all at Datascope? I mean,
The process?
yeah.
Or
where did you learn? I got the takeaways. Where did you learn? Did you do this kind of stuff before?
Well,
Design work?
I guess it kind of started before Datascope. Actually, this is something that McCormick in general, especially well, specifically in their undergrad, has really been focusing a lot on recently. So at the very least, everybody who comes to Northwestern as a McCormick undergrad does 2 quarters of what they're now calling DTC, which is Design Thinking and Communication. And you do like you basically go through this process a couple times for real clients, actually. So I did one project for a quarter for a science magnet school in Rogers Park that had a greenhouse. So we designed some like greenhouse things to keep it safe because they didn't slope the floors. So if the floors got wet, kids were just like slipping all over the place. So we had to keep water off the floors somehow, but also be able to water plants. So that was kind of a cool problem. And then I did another one for a jewelry store in Evanston, which is more of like almost like an interior design type of thing, but not in like the make things pretty kind of way, and the like make people's offices not terrible kind of way. But yeah, I mean, that's kind of where it started, I guess. And then obviously at Datascope, I've been able to apply more of like the data science and programming side to these types of things. But the process really, it doesn't change all that much from problem area to problem area. But like I said, it's like they're muscles that we don't exercise very often. And so it's just kind of doing it a lot that you learn, I would say. Well, I'm happy to stick around and talk to people in a more casual setting too. I guess we have probably lots of pizza left, so
Yeah.
Thanks for having me, Jeremy.
Oh, thank you very much. Can we give another hand? So,